We're going to move to our first presentation of the morning. We have Sid Dutta, who is Senior Data Security Products Executive at Focus, and Sid is also on the Ohio River Valley Chapter Board of Directors. Sid leads product management for Voltage Secure Solutions, focusing on cloud enablement and integrations, big data analytics, and data security as a service. Sid comes from the enterprise side and has led cybersecurity risk remediation programs and services globally at various large corporations and on financial services sector. He has deep experience driving data-centric protection and key management across on-premises and public cloud hosted applications and data to address regulatory compliance. Prior to Micro Focus, Sid was Vice President and Global Head of Data Protection and Applied Cryptography at WorldPay from FIS and Director of Information Security at American Express. Sid also holds a Chief Information Security Advisor role in Fractalis Labs, Dialogan, and a Director of Programs role on the Board of Security of the Cloud Security Alliance. And so with that, Sid, I'll turn it over to you.
Well, thank you, Greg. Good morning, everyone. Hopefully everyone can see the slide.
Yep, it's playing.
All right, very good. All right, so thank you everyone for joining. Of course, today's topic, key management in public cloud, and what I'm going to be covering is, providing some information around the public cloud service provider and their own offerings in the key management, and then certain things to watch out for, and then obviously some of the recommendations, and how I see it, based on my experience and research. In terms of leveraging key management and crypto services, and particularly when it comes to data that's being stored in the cloud, and not just one cloud, multiple clouds, as well as hybrid. So there's no surprise here. Cloud is here, cloud is happening, cloud is inevitable, and many companies are adopting multi-cloud or hybrid cloud strategy to augment their internal data centers. Which often creates many different systems and ways of managing the life cycle of encryption keys, when it comes to protecting their sensitive data, and managing keys in 5 or 6 different hybrid public cloud and on-premises environments obviously increases complexity, cost, and of course security risks. So basically, this session is going to talk a little bit about what are the cloud services provider doing in order to offer their customers to protect their data, and as well as how each of these services across, we're going to cover a little bit about just the big 3 cloud services providers: Amazon Web Services, Azure, and Google Cloud. Some of the similarities and of course some nuances and value propositions that each of them are offering. Before we go into the table of contents to kind of go through that and jump right into the topic, this is one of the slides that I thought was very important, and very, very often ignored in terms of understanding the cloud shared responsibility model. And of course, I've just used AWS's shared responsibility model picture as a reference model, but the same applies for the other clouds as well. So it's very important in order to understand what's the difference between responsibility for security off the cloud and the responsibility for security in the cloud. And as you can see from the diagram, that there are certain things that even though the cloud providers actually provide by default, it should not be interpreted as the cloud service providers have the responsibility of protecting the customer data. It's actually the onus is on the customer. And of course, some of the breaches that have happened is found that misconfiguration happens to be the #1 cause of data breaches in the cloud, because probably someone stored something in a cloud storage bucket and exposed that to the internet, even though the default server-side encryption was turned on. And then, of course, hackers are always going after servers that haven't been configured correctly. So, providing these compensating controls, perimeter controls is complicated, and then the whole defense in depth strategy is great, but it just needs one miss, across these various layers to open the door to any bad actor. So that's why it's very important to understand, how would you implement data security and leverage the right key management solution and what type of data-centric protection you need to apply. And in this case, what the cloud services providers are offering. So it's a high-level table of contents. So we're going to go over some of these, and then conclude with things to watch out for and some recommendations. So let's jump right into our first subsection, which is Key Management Service, KMS overview. The cloud KMS, and of course, across the three clouds, you have the AWS KMS, which is a service offered by AWS, in Azure Key Vault, and from Microsoft, and then of course Google KMS from Google Cloud. Now, these KMSs typically expose APIs for managing keys and secrets. There are encryption keys, API keys, possibly some secrets, like passwords. And so some of these things, you can actually store there. Now, when it comes to data protection or encryption keys in order to protect data, all of these KMS services actually work on the premise of the master key and the working key model. And I'm going to expand what I mean by that. So when we talk about a master key, or sometimes referred to as customer master key, or even customer managed key. So the acronym that's used is CMK. You will hear that term, very widely used, and even when you look through documentation across, all three cloud service providers, the word CMK comes in. Now, a customer master key, or a CMK, or a customer managed key, is what that resides inside, the KMS, and they never leave the KMS, which is a very important information to have. Now, what is this CMK used for? Now, they are used to either generate data encryption keys or to protect data encryption keys. And the distinction here is that the CMK is seldom used to protect data because there is a data encryption key which either can be generated locally, within an application construct, or the KMS can be used with a CMK to generate that data encryption key. The data encryption key is what is used to protect sensitive data, in bulk. The CMK is not typically used, for encrypting data in bulk. I mean, it can be used to encrypt other secrets, like it can be used to encrypt a data encryption key. It could be used to encrypt an API secret or a password or any other secrets that you're storing. But the CMK is what the function of it is to either generate the data encryption key or to protect the data encryption key. And the CMK could be symmetric or asymmetric. AWS offers AES 256 in GCM mode. GCP offers AES 256 and GCM mode. Azure so far haven't provisioned a symmetric version of CMK, but they do provide asymmetric CMKs. And AWS and Google obviously both support asymmetric CMKs as well. Now, there are certain limitations in the capability in encrypting sensitive data in bulk. So if you are planning to use the CMK as your data encryption key, then all of these service providers actually impose some restrictions. So like AWS will limit the size of the data to 4 kilobytes. And anything beyond that, you can't really use the AWS CMK to protect it. And even rate of encryption limits is also not that high. So the message here is that the CMK is not really the key that is used in order to protect data. It's there to protect the data encryption key, which you could have generated locally or via the CMK. Now the CMKs are, from an access control, from a customer manageability perspective, also differs in terms of the type of service you are using. So it could be a customer managed master key. That means a customer can both view the key metadata and manage the key. It could be a cloud service provider managed master key. That means the customer can view the key metadata but cannot manage the key. Or it could be an entirely cloud service provider owned master key, and customer neither can view the key metadata nor can manage the key. So it's totally opaque from a customer standpoint. And there are certain services that AWS or Google or Azure, they will manage those master keys where the customer has really no control or visibility in there. So that's about the master key, CMK, and data encryption keys. Now, of course, data encryption keys, as I mentioned, it could be generated out of the CMK or locally. AWS, they offer APIs to generate working keys from the CMK or the KMS. Or in other cases like Google and Azure, they will ask the applications or application teams to generate those keys locally and then use a CMK to protect them. And I'm going to talk a little bit about the model that how the CMK and the data encryption keys are relevant when it comes to protecting data and in what form the data is actually stored. So the next service that we're going to talk a little bit about is a cloud HSM. Now, outside of the KMS, they are also offering HSM services in the cloud. It's a model where the keys are stored in FIPS 140-2 compliant HSMs that are hosted by the CSP, in this case, a cloud service provider, but managed by the customer, from their own VPCs or virtual network, and they are dedicated to them, typically in a single tenant model. Now, the application running in any of these clouds could directly consume the Cloud HSM APIs, or they can actually consume the KMS, and at the back end, the KMS can also use a Cloud HSM if the customer has one, and opts for a custom key store setting. So typically in a KMS, when you decide where you want to store that CMK, you can specify that it can be managed in the software, meaning in the KMS itself, or you can specify a custom key store setting saying that, okay, I want my keys to be stored in an HSM, but my access to that key will be via the KMS. So there's obviously certain nuances to that, and typically not all keys are probably going to be in Cloud HSM. In other cases, a customer may not opt for Cloud HSM for various reasons, if they're not mandated to from a compliance perspective, or if it's in an additional overhead or cost from their overall cloud security portfolio perspective. Now, Cloud HSMs actually have a higher throughput than the KMS-based model of encryption. And so these are, the services, you've got the AWS Cloud HSM, the Azure Cloud HSM, as well as the Google Cloud HSM. And these HSMs actually offer, or supports, standard APIs, including PKCS11, OpenSSL, JCA, JCE, CAPI, CNG, and they are exposed either directly through the Cloud HSM client or SDKs that you can actually use, and the cloud services providers will actually make it available for you. Or you can, as I mentioned, use through the KMS interface and take advantage of other cloud services integration existing within KMS. Now, Cloud HSM supports obviously symmetric, asymmetric, message digests, HMAC, digital signature, and stuff like that. When you dig deep into some of the compliance aspect of the HSMs, not all cloud services providers will specify the level of FIPS 140-2 compliance. There was obviously, you've got level 1, level 2, level 3, level 4. But a lot of cases, now they've started to make in public, like AWS, they support level 3. FIPS 140-2 level 3 compliance for their Cloud HSM, and even common criteria and EL4+. And the products that they use, internally to offer as a Cloud HSM, even though that's really relevant in terms of when you're consuming a service. But if you really wanted to understand that, okay, we use certain HSMs on premises, what products the cloud services providers are using. So there are multiple that the cloud services providers actually partner with and offer within their service. There's of course Thales, Gemalto, SafeNet, Luna HSM. AWS has been offering, I think, since 2013, and then they launched a new model in 2017, with another HSM manufacturer, Cavium. GCP, a Google HSM, is also a Cavium product. And Azure also uses, Thales, Gemalto, and possibly, in Cipher and in Trust as well. So this one interesting concept I wanted to introduce, the concept of envelope encryption. And that is basically kind of the premise of how this CMK and data encryption keys, customer managed key and data encryption key, how they work in that ecosystem. So to define, envelope encryption is the practice of encrypting clear text data with a data key, and then encrypting the data key with another key, and then storing the encrypted data and the encrypted key together, as an envelope. So, a picture is worth 1,000 words. So here, if you look at, and this is an AWS example. So you've got the KMS service, and you have the CMK, or the customer managed key, customer master key, stored inside AWS. And through the interface, the application actually can call the generate data key function, the API, that would give them the key in plain text, and also it will use the CMK to encrypt that plain text data key, and it will send two versions of the key. One is the encrypted version of the key, and one is the plain text version of the key. Now, the data that you're trying to protect within your application will use the clear text version of the key and encrypt the data. And then the encrypted data and the encrypted key, they will be stored together as an envelope. So basically what happens here is that you have the ability to generate unique keys for every single data element, and you don't really have to keep track of what key was used to encrypt what data, so that you can use that same key in order to decrypt that data. Because the encrypted data and the encrypted key are stored together, so that correlation is always maintained in the context of envelope encryption. So let's say if you encrypted Bob with key 1 and encrypted John with key 2, encrypted version of Bob and encrypted version of key 1, they will be stored together, and encrypted version of John and encrypted version of key 2 will be stored together. So when you need to decrypt John or the ciphertext of John, when you look for it, you know which key was used because it's right there, against or right beside the encrypted or ciphertext of John. So that's basically the encryption flow that once you're storing. Now, when you need to decrypt it, what happens? So since the encrypted message and the encrypted key are stored, you obviously need to decrypt the encrypted key. So you make a call back again to the KMS and specify which CMK was used in order to protect that key. And that CMK will be used to decrypt the key, inside the KMS. And then you get back the plain text key. And then you use the plain text key to decrypt the encrypted message or the data. So one more time, you take a encrypted version of the key and the plain text version of the key out of the KMS. And in other cases, like with Azure and Google, you can generate the data encryption key, the plain text, locally, and then send it to the Azure Key Vault or Google KMS to get it encrypted. So you got the encrypted version of the key as well. Now you use the plain text key to encrypt data, and you store the encrypted data and encrypted key together. When it comes to decryption, you send the encrypted key back to the KMS to get it decrypted. Once you obtain the plain text key, you decrypt the encrypted data. So that's how envelope encryption works. And that's kind of the model how all three cloud services providers are offering in terms of application level encryption, data centric encryption, using KMS and Cloud HSM at the back end or directly to manage your keys. This is another interesting concept that a lot of you are probably familiar with and have probably heard about this term. And the cloud services providers, they are essentially offering that capability as well. This is not new. Even before the top big three cloud services providers started to offer, there were other SaaS providers, who actually allowed this ability, because there's a lot of concern in terms of cloud services providers generating the keys and managing the keys that are used, for protecting the data in the cloud. So a lot of enterprises, are hesitant to lose control of the key management, and even from other aspects, the type of keys that would be used. So this option just gives another flexibility in terms of how you can at least have control of maybe not the data encryption keys, but at least the root keys. And I'm going to show you how this model works. So on the left-hand side, you can see customer application 1, customer application N. And so all of these applications are basically going to be processing sensitive data, so they need to encrypt. Now, what happens is the cloud services provider KMS, that we discussed that they stored that customer managed key, or the CMK. Now, this CMK material, the key material, either could be generated here, or you could generate it outside of the cloud services provider's premises or their services, and then push that into the cloud services provider's KMS. So what happens is the whole process works is cloud services providers, and typically, it's pretty similar across all three. There's certain nuances. So the process to essentially push your key, if you are locally generating within your enterprise, and if you have an HSM and you're generating there, and then you want that key to be pushed into the cloud KMS, so for these applications to consume, you typically download a bring your own key certificate, public key, or an import token, which is kind of optional depending on which cloud services provider you're using. Now, what happens is once you've downloaded the certificate and public key, you generate the key material. That's in this case symmetric, and that key material could be generated within software, or you have a HSM on premises that you can use. Now, once you've generated that symmetric key, then you take that public key, that you obtained from the cloud services provider, and encrypt the key material with that public key. And then you do some sort of padding and encoding of that encrypted key material, which is also optional depending on which cloud services providers you're using and what they allow. And for integrity perspective, you can even perform a cryptographic hash on the plain text key material, and then send the encrypted key with encoding and padding and the hash, back to the cloud services provider KMS. Now, the cloud services provider KMS has the private key, for the pair that they actually sent that certificate and the public key for, and they would decrypt the payload and unwrap the key material, validate the token and the hash, and then see the message hasn't been tampered with. And then they will upload the key material into the KMS. So now what you have is the same model, envelope encryption applications using the CMK inside the KMS to either generate a data encryption key or to encrypt a data encryption key. The same model, but the only difference is that that CMK key material was generated by the enterprise customer, possibly within their own data center, software or HSM, and then that got pushed in there. So here the control, that what key material is used, the strength of the key, all these things are going to be managed by the customer. Now, multiple keys in the key hierarchy, obviously, as we mentioned that in a lot of cases, the actual data encryption key could be just one level, below the CMK. That means it could be just generated by the CMK, or there could be multiple layers. In a lot of cases where some of these services are probably using a third level or a fourth level in the tier. So there should not be any misperception about that. When I do bring your own key, I'm actually bringing in the data encryption keys. And that's the key that is being used to protect my sensitive data. So typically all BYOK mechanism apply to that top level customer managed key or master key. And when it comes to key rotation, that's where the key rotation happens. So when you rotate data encryption keys, obviously that's an impact, right? Because you have encrypted a lot of data with a data encryption key, and now if you have to rotate it, that means your previously encrypted data has to, get re-encrypted, with the new data encryption key. So that's a hassle and a pretty big pain point for enterprises. So the the key rotation concept has shifted up in the tier, that what you rotate is not what actually protects your data. It actually protects the keys that were used to protect your data. So when CMKs are rotated, it doesn't impact the data that you have encrypted, and the data encryption keys are essentially rewrapped with a new CMK. So that's one of the things to understand when it comes to bring your own key, or in general key rotation. And of course, when it comes to your compliance, that how many years or months you're going to be rotating keys, from an auditor's perspective, are you complying to that? I mean, they're going to be asking for proof in terms of, how often are you rotating, and show that these keys are being rotated. Now, there's another concept. Bring your own key management service. So this is something I think a couple of the cloud services providers have recently opened up. Now, we talked about BYOK. What's BYOKMS? What this means is that the same model applies. Your data encryption keys are protected by customer managed keys, and those customer managed keys are stored inside the cloud services provider's KMS. But the customer managed keys are now further encrypted by another key, which is outside of the cloud services provider's service. So you could actually have an internal system, or use something that is external or a cloud service provider, but not managed by the cloud services provider like AWS, Azure, or Google Cloud, where your applications are. You're just using something that is external, and the CMK that is stored in the cloud services provider KMS is encrypted by a key that you manage. Now that key could be generated inside software, or essentially generated from an HSM as well. So what happens in the flow is you have an encrypted data key, and you need to use that key to protect or decrypt encrypted data. So you go back to the KMS to get that data encryption key decrypted. But hold on, the CMK inside the KMS is encrypted as well. So this needs to be decrypted. But where is that decryption key? It's not here. So you'll have to go outside of the KMS and outside of the cloud services provider's perimeter to this cloud agnostic or enterprise owned, managed and hosted key management service, which will decrypt that CMK. So you get the plain text CMK now, and then you use the plain text CMK to decrypt the encrypted data encryption key, and then you can use the plain text data encryption key to perform your operation. So this is kind of another layer that it gives one additional control, and even this kill switch mechanism. Let's consider that, okay, if the cloud KMS got hacked, right? The hackers are essentially ending up with a bunch of customer managed keys that are encrypted. Now, if you kill this connection from the cloud and this system that you're probably hosting somewhere outside of the cloud services provider, then there's no way these keys can be decrypted. And that means none of the data encryption keys can be decrypted, and hence the data would be secure. So that's one good mechanism in terms of how this additional system and the additional key in the hierarchy provides some sort of defense mechanism in case the KMS got attacked. But on the other side, you're adding one more layer in the whole ecosystem when it comes to transactional workloads, where every key has to now, to get decrypted, has to travel two places. One, it has to come here, and this has to make a call externally, and then you're adding more latency and performance overhead. Plus, if this network isn't reliable, or this system isn't reliable, because this is outside of cloud services providers' control, this is managed by the enterprise or possibly another third party, then you're stuck, because if you can't connect to this system from the cloud, then you can decrypt your CMK, and hence your data will not be able to be decrypted. So you'll have a bunch of failures in there. So Google Cloud offers, I think Azure also does the same thing. So you can see here, like we used an example of like BigQuery. So users are connecting to BigQuery, and data is encrypted, and then obviously that run searches and queries and get the decrypted results from BigQuery. It has to go into the key management service. The key management service has the encrypted CMK, which is essentially accessing this external key manager, which is a third party or enterprise owned, through this external key manager service, and then gets that encrypted key decrypted, and then the CMK, the plain text CMK, is used to decrypt the data encryption key, which are used for data stored in BigQuery. So this external key manager service offered by Google, and Azure has a similar one, that has kind of given an additional option for enterprises to consider, to add one more layer of key hierarchy, which is not residing inside the cloud services provider's KMS. Because when we talked about the bring your own key, you are pushing the key inside the KMS. And then of course, now the cloud services provider hosts it, right? And there's always this debate about what cloud service providers, personnel, or administrators can see or not. But there's obviously those concerns regarding that, at the end of the day, it's stored there. In this model, you're just adding one more layer in the key hierarchy, where the final key, because if that is lost or destroyed, or you can't find it or connect to it, will basically negate everything that you do in the cloud from a key management perspective. Because if that final key isn't available, then everything inside the KMS is encrypted, and you can't use those keys to decrypt your data. One interesting additional service that Google offers in the context of encryption, and why it's important, and why I included in today's presentation, I'm going to talk about it a little bit. So Google has this product called Cloud DLP, and basically what it does, it exposes APIs for sensitive data inspection, classification, and de-identification. So if you have, let's say, a bunch of data being streamed, and you want to understand that the data that's coming to me from an external source, because I have not really classified that data before, this is new raw data. Are they sensitive or not? Because if they're going into, let's say, a data warehouse, an analytics platform, or let's say even IoT, for that matter, is that data sensitive? Should I be protecting it before I store it? So it's all these decisions can only be made after I know, what's the DNA of that data. So you can call the DLP API to say, let's say, inspect. So basically, they offer, three APIs. One is an inspect API, which basically will tell you that, hey, I'm just sending you the data. Tell me, is this sensitive or not? And then the Google DLP has this built-in dictionaries, and you can also add your custom dictionaries as well in terms of finding out whether it's a credit card number, whether it's a social security, whether it's a name, it's an address, any medical data or whatever. And then based on that, if the results come back that this data is a credit card number or a social security or national identifier or something that is personal information, then you have the ability to take action on it. Now, one of the actions would be that I would want to de-identify that. So you will call this de-identify API, saying that, okay, it's a credit card number, encrypt it. And as part of the de-identification, Google actually offers even format preserving encryption, which is obviously a great tool. We all know it's a very powerful technology in terms of how you protect data without losing the referential integrity of that data, without having to expand your storage and database schemas because the length and format are preserved. And it's a NIST approved, standard, as long as you're using FF1 or FF3-1. And the keys, for the de-identification could be managed three different ways. One is that the application which is calling the Google DLP API can generate the key locally and embed that key in the API request header in the clear. So that's a concern. Or it could be wrapped by a master key, CMK within Google KMS, and then sent as part of the API call, which is better because now you don't have the keys exposed in the API call, just because you're using a header, so it could get logged. But you have an encrypted key now, and then you have to go back to the KMS to decrypt it, the whole drill that you have to do. Or you can just basically delegate that to Cloud DLP to use a key within the system that it has. And obviously at the back end, it's connecting to the KMS, the Google KMS. So that's a little bit about Cloud DLP. Now, this is typically not used for bulk operation. This is typically probably will be used in a ad hoc basis when new data has arrived and you want to introduce this additional flow. You would not call the format preserving encryption de-identify API on Google Cloud DLP when you are working on bulk data or analytics and stuff like that. For that, you will leverage your application level SDKs and then use the KMS in order to do that. All right, so these are kind of the things that I went through. We talked about the KMS services, the Cloud HSM services. We talked about envelope encryption, bring your own key, bring your own KMS, and then we talked about Cloud DLP. And some of the things to watch out for. Now, of course, each of these systems and services within each cloud obviously are offered within the perimeters of that same cloud. It's kind of a given. But we know that pretty much 9 out of 10 enterprises, they are using multi-cloud, for the various services. And typically those are driven based on their choice of using the best of the breed. there are other areas where mergers and acquisitions have kind of created this ecosystem where the company they acquired used one cloud, and the acquiring company used another, and of course you're maintaining multiple cloud, and then of course there's shadow IT and all this stuff. So bottom line, very very few enterprises are single cloud, right? So there's multiple clouds. Now how do you manage your keys and your data across multiple clouds, because each of them has their own, and there's no portability across. And a lot of cases when you're migrating data from one cloud to the other, let's say you wanted to use one particular data warehouse service and then you found another one and want to move there. So let's say you want to centralize your data warehousing capability to a specific cloud services provider, and may not be all three or any of the three. It could be something like Snowflake, which is a third party SaaS data warehouse service hosted in any of these clouds. You don't want to go into this model where data that was encrypted in AWS, once you have to move it to Azure or somewhere else, has to be re-encrypted, right, in bulk. I mean, that's a very very painful exercise. So how do you really do key management in a way that it's portable across, and not just across multiple clouds, but even on premises? How do you have an enterprise key management service that scales and spans, from on premises to one or more clouds? So that's something to watch out for. I think the cloud services providers have done a great job, offering these capabilities as we went through. But at the end of the day, these services are constrained within or confined, within their service perimeter. Some of the things, are kind of complicated and debatable in terms of the control of keys. And I talked about the customer managed key, where customer can both view key metadata and manage, versus CSP managed key versus CSP owned key, where the customer really has no visibility whatsoever. And at the end of the day, it's stored inside the cloud services providers. And there's a lot of debate about what the cloud services provider can see or do, and how do you restrict them from certain things. So there's obviously things to watch out for to understand what sort of control you have as a customer. Homogeneity, this is another thing that is not really understood too much, because there are some nuances in terms of how data is protected across various services, and the SDKs that are used, that are built in or natively offered for those services, how they don't talk to each other. And I'm not going to give any specific example or call out any particular cloud. My own personal experience is that probably I used certain thing on the application level, and then I tried to use a data warehouse where I stored my data, and that SDK to decrypt that data, it wasn't compatible. And cloud services providers will actually make that very clear, what talks to what and what doesn't. So there's a lack of homogeneity, and not only just from the services perspective about compatibility, but even when you're going across multiple regions, some services are not available there from a key management perspective. So if you're operating in a particular cloud region or availability zone, and that region doesn't offer a particular service that, let's say a North American region did. So these are some of the things that you got to be watching out for, particularly for global enterprises who are deploying applications in the cloud globally. Key management abstraction level, and as you saw, from envelope encryption and the concept of data encryption keys being generated locally by the application developers. The access to the physical keys are with the developers, and then they essentially make those decisions of how to use those keys, where to store those keys, how to protect those keys. So the notion of how do you take away the requirement from the application developers to understand crypto, to understand key management, because that's not their expertise. They want to build business application to create more revenue and value for the company. Security has to be built in, and it should be there by default. So there's hardly any key management abstraction. I mean, you essentially are exposed with APIs, and once you get the keys, and you control that. And in a lot of cases, those could create more exposure, like someone maybe generating a key locally, never using the KMS to protect that in that envelope encryption model, and just storing that key in a database table, and just providing some sort of access control that who can actually get to the key, and that key is probably lying there in the clear. So the level of abstraction is very minimal. So you don't shield this whole concept of key management under the covers, that the developers don't have to worry about it. Some are really good, to do that, and they all want to do the right thing. But a lot of cases they don't understand, and that's why some of these things happen. And how many times we have heard people have hard coded keys or secrets in their code, or put that in a properties file. So these are some of the things that are very important to understand. Encryption format choices. So other than Google, and also Google in this case only with DLP, but none of their KMS offers the ability for you to do tokenization or format preserving encryption. It's AES 256, GCM mode, and the ability for you to generate a token that is length preserved, format preserved, is not available across these three cloud services providers, except for that Google DLP de-identify API. But the other sophisticated data obfuscation options, like Unicode, format preserving anonymization, like if you want to create a hash, and make it irreversible, but you still want to retain the format and length of that data. Some of these things are not available. So those some of the things you got to figure out, that what's my need in terms of doing analytics and other, even like test data management and stuff, and what options are available for me while using these KMS services. As I said, there's a lot of confusion about the understanding of that shared responsibility model. What's security of the cloud versus security in the cloud, and who's responsible for what. Typically, you drop a file in S3 bucket, and by default server-side encryption is turned on. But that doesn't really buy you a lot when it comes to preventing your data from getting breached, because there's this difference between an incident and a breach. An incident is when the confidentiality, availability, integrity of your data has been compromised. But a breach is when that data essentially has fallen into the hands of a perpetrator or hacker, and has exposed the customer in a bad way. So you probably cannot prevent an incident from happening, but you can definitely prevent breaches, or the incident to escalate to a breach. That can be prevented. But server-side encryption, transparent encryption, and they don't really buy you a lot. Sometimes it's a checkbox. And envelope encryption and Google Cloud DLP usage I talked about, because these are all API driven, and envelope encryption, as you can understand that, since you are using the CMK to protect the data encryption keys, so for any time you want to decrypt, you gotta go back to the KMS. So that's a trip that you have to make. Sometimes it's not performant enough. And of course, if you lose the ability to connect, then essentially you lose the ability to decrypt data. Now we've got 5 minutes, so I'll just quickly browse through some of the recommendations here. Of course, avoid vendor lock-in and ensure portability and extensibility, and the adequate control of keys across all platforms. Drive towards more stateless encryption services and key management. When you have a key store, there's a lot of overhead that comes to it, even though the cloud services provider is probably managing it for you. But then there are other things to even think about regarding portability and synchronization. If you're operating in one AWS region, and there's another business unit in Asia Pac, and you're using another region, will I have access on my applications? Will I have access to the keys in the KMS that was in North America, versus somewhere in Asia Pac? And high availability resiliency, these are very important. A lot of people focus on the security aspect, but the practical consideration of is my availability going to be impacted? If there is a network outage, would I lose the ability to decrypt data or provide value to my customer just because I've done something that is dependent on other factors that I don't control? Strive for performance while not compromising security. So performance is a big deal. People are talking about tens of microsecond to millisecond level performance, particularly with running queries and stuff. So you can really have a model where there's a network trip involved for every data to be decrypted, and that adds tens and hundreds of milliseconds to your performance. And abstract as much as possible from a key management perspective from the developers, because they should not be worried about key management and crypto. They should be writing good applications which security is baked in and data is protected. And feature-rich crypto. So there's multiple ways and better ways to perform crypto, and not just the traditional ways where it breaks a lot of stuff. And consider the BYOK and BYOKMS for appropriate use cases only, where you can't really take your encryption into the cloud. Bring your own key would probably be your own the only option there. So consider those as as fit for purpose. Right. With that, I come to the end of presentation. Thank you, Greg.
Thank you, Sid. And we've got quite a few questions for you here. I don't know if you've had a chance to look at the chat window here, but let's go through some of the questions that were posted for you.
Sure.
And then another participant posted that Andy said that the envelope encryption sounds like a dual lock. Any comments on that?
Yeah, in a sense, it could be looked at that. Yeah, but it's a good way, to essentially have a lot more key diversity. And sometimes, if you really think about it, that if every data element is encrypted with a unique key, and then that data element in the encrypted form and the key in the encrypted form are stored together, you basically negate the need for key rotation, because your key is never reused. So in a lot of cases, that comes out very handy. Yes, there are real challenges with envelope encryption, and I'm not sure how many enterprises are actually doing it in its true form. But there are certain advantages as well, because then if this one key that is protected used to protect only one data, then you don't run into those issues of that. Okay, I have to rotate these keys because that key has been used for encrypting millions and billions of records, and the risk, because if that key was compromised, that only single data field will be compromised.
Okay, and then Andy was also wondering if there's a specific key exchange standard for communications, for example, BYOK.
Yeah, so I think that the BYOK obviously is not really using any particular key management interoperability like a KMIP or anything like that, because that typically is exposed when you're essentially obtaining a key from a KMS, and the KMIP is that interoperability protocol that allows you to do that. But cloud services providers will just offer you APIs that essentially are custom. But on the BYOK side, it's really an offline activity because it's not transactional. So what happens is it's a user, an administrator will basically go and download that certificate and then generate the key locally, wrap the key with the public key, and then upload it. So it's very transactional and user driven that these cloud services providers will expose through the portal.